In question 1, figure 1.1 shows an ice hockey player moving on ice. He's preparing to hit the solid disc called a puck. The disc of mass 0.16 kg is moving horizontally across the surface of the ice at a speed of 15 meters per second. Calculate the magnitude of momentum of the disc. So what is the momentum of the disc? As we know, momentum is a product of mass and velocity. So mass multiplied by velocity. So 0.16 multiplied by the speed at which it is moving, that is 15. So you will get 2.4 kilogram meter per second. The next part, a hockey player strike the disc with his hockey stick and the momentum of the disc changes. The disc gains a momentum of 3 kilogram meter per second at 45. So basically this is a new momentum which is 3 kilogram meter per second at an angle of 45 to the original. And what was the original momentum which we calculated? The original momentum was 2.4 kilogram meter per second. So that was the original momentum in this direction. That's 2.4 kilogram meter per second. The next part, they're asking state the magnitude of the impulse exerted on the disk and the direction in degree of impulse relative to original direction. So basically impulse, what we call impulse is a change in the momentum. So what is the change in the momentum? How we'll work out the change in momentum? And we want the change, state the magnitude of impulse exerted on the disk and the direction in degree of impulse relative to original direction. So relative to original direction, how we can work out? Look, because it is a vector quantity, so when it is a vector quantity, there is no momentum in this direction. Originally momentum is in a horizontal direction, then the new momentum is in 45 degree to the original direction. So what is the change in momentum in this direction? As they mentioned, this is 3 kilogram meter per second. So what is the horizontal momentum? That is already we calculated, which was 2.4 kilogram meter per second. But in the question, they're asking the change in the momentum. So how we will calculate a change in the momentum? It is final minus initial. So this is a final. But what about the initial? What is the initial momentum in this direction? In this direction, there is no initial momentum. So that is why the initial momentum will take as 0. Why we are taking initial momentum 0? Because initially the disc was moving horizontally, and when the player strike it, it move and make a certain angle. So the momentum, which is or impulse or momentum, these are vector quantity. So if we need a gain in momentum or impulse in this direction, so if you want to calculate impulse in this direction, the final momentum is 3 kilogram meter per second. What is the initial momentum in the same direction? The disc was not initially moving in this direction. That's why the initial momentum is 0. So when we calculate the impulse is the change in the momentum. It will be 3 minus 2.4 if in the question it was like the object was initially moving with a momentum of 2.4 and then it changes the momentum in the same direction to 3 kilogram meter per second. If the question was calculate the impulse or change in momentum, so in that case it will be 3 minus 2.4. That is right. But here what happened? Originally the object was moving horizontally and then it is making certain angle. This is 3 kilogram meter per second. So whenever we calculate an impulse, we take the initial and final in the same direction. So initially the object was not moving in this direction. That's why initial momentum is considered to be 0 kilogram meter per second and final is 3. So when we calculate the impulse or magnitude of impulse, so actually it is 3 minus 0. So that is equals to 3 Newton second. Is it clear, this part? The next, direction of the impulse to the original. So direction of the impulse is same as the direction in which the momentum changes. So momentum change. Yes, we can write 3 kilogram meter per second. That can also be used. You can write 3 kilogram meter per second or you can write 3 Newton second. That is the same thing. Reason for that, it's the same unit, no difference. Final momentum is, originally the object was moving with a momentum of 2.4 kilogram meter per second. Then it changes the momentum, it gained a momentum and it gained 3 kilogram meter per second. The question is, state the magnitude of impulse exerted on the disk and the direction in degrees of impulse relative to the original direction. So what is the magnitude of impulse? Impulse is a change in momentum. So originally the object was moving horizontally and then it is making certain angle and moving with a momentum of 3 kilogram meter per second. Because at this point there was no component, initially there was no component in the same direction. That's why initial momentum in this direction is 0 and the final momentum is 3. So when you calculate an impulse, it will be 3 minus 0, which is equals to 3 kilogram meter per second, or you can also say 3 Newton second, which is also a unit of impulse. And what about the direction of this impulse? The direction of the impulse is same as the direction of momentum, the change in momentum. So the change in momentum in this direction, so impulse is also in the same direction as it is a vector quantity. So here you will have 3 Newton second and the direction of the impulse will be 45 degrees to the original one. The next part, determine the magnitude of new momentum of a disk and its new direction relative to original direction of travel by the scale diagram. So we have to use a scale diagram or a vector diagram. Look, original momentum was 2.4 kilogram meter per second. The change in the momentum or the gain in the momentum, that is 3 kilogram meter per second, and the angle between them is 45. So what we have to do, we have to use a scale diagram to find the resultant, because determine the magnitude of new momentum. So what will be the magnitude of new momentum? So we have to use a scale diagram. In a scale diagram, first you have to select a proper scale like 2.4 and 3 kilogram. It should be in, you have to select a scale by yourself. So example, if I select that 1 centimeter, 1 centimeter is equals to 1 kilogram meter per second. So 2.4 centimeter will be equal to 2.4 kilogram meter per second. And 3 centimeter will be equal to 3 kilogram meter per second. There are now, we have two options to solve this question. We can either use a triangle method or a parallelogram method. but I advise that you use a parallelogram method, because in a parallelogram we need angle between the two vectors, and normally in the question they provide this angle between the two vectors. So if I use a parallelogram, I will explain both methods. So if I use a parallelogram method, first what we will do, 2.4 is there, so we'll draw a line of 2.4 centimeter. So first draw a line of 2.4 centimeter, because 2.4 kilogram meter per second is 2.4 centimeter. Then you will place a protractor and mark 45 degrees and draw the vector, the second vector, which is 3 kilogram meter per second or 3 centimeter. So using a ruler, you will measure 3 centimeter and draw a line of length 3 centimeter. Now what you will do, you need a diagonal. How you find a diagonal? So you can draw a compass, you can open a compass of a length 2.4 and place it on the opposite side, like at point A, and draw an arc of length 2.4. Then you can open the compass of length 3 centimeter, place it on point B and draw an arc. The point where the two arcs will intersect, you will join that to get a diagonal of the parallelogram, and this diagonal of the parallelogram is our resultant. How we will know what is the magnitude of the resultant? The term magnitude means value. So you have to measure the length of this diagonal. It can be any specific length. Using a ruler, you have to measure a length of this diagonal. Example, if it is 5 centimeter. So if this length is 5 centimeter, so we know the scale 1 centimeter is 1 kilogram meter per second. So 5 centimeter means the resultant is actually 5 kilogram meter per second. And angle means that they ask direction with the original direction, means angle with original. So original direction is same as this 2.4. So using a protractor, because in this direction, the Hashim, the thing is, in the question they specify you should draw a scale diagram. So a scale diagram means it should be not with formulas, it should be done with measurements. And you cannot use a formula here. Reason for that, why you cannot use a formula? Because the change in the momentum is not in the same direction. If the momentum or change in momentum are in the same direction, you can use a formula. But in this question, initially it was moving horizontally and then it is making certain angle. So direction changes, so you cannot use the formula in this case. So you will measure the angle. So example, if this angle is 25, so you will write that as 25. So answer, this will be 5 kilogram meter per second and the direction from original is 25. How you will know whether you did right or wrong? So if you complete this figure, it should make a parallelogram. That's why this method is called a parallelogram method. So if it is making a perfect parallelogram, even rectangle is formed. Rectangle is also a parallelogram. So even rectangle or parallelogram form, it means you did accurately. If, for example, it does not appear to be a parallelogram, it means you did any mistake in the measurements or drawing the arcs or length of the sides. This is, you can use the parallelogram method. So what simply we'll do, the two vectors are given. We have two vectors. So first we'll select a proper scale for the two vectors. And after selecting a scale, we'll draw the first vector. So example, this is a question. You have to find a resultant of these two vectors. So first you will select a scale as I did here, that 1 centimeter is 1 kilogram meter per second. Then you will draw a line of 2.4 centimeter. Then use a protractor, mark 45 degrees, draw a line of 3 centimeter. Then open the compass, because I need a parallel side. So I will open a compass 2.4 centimeter and draw an arc from other side. Then I will open the compass 3 centimeter and draw an arc. The point where the two arcs will intersect, I will join the point, the starting point with the arcs. That is a diagonal. And diagonal in a parallelogram is a resultant of the two vectors. You can also use a vector diagram for a triangle method. You can use a triangle method as well, like this is 2.4 kilogram meter per second and this one is 3 kilogram meter per second and the angle between them is 45. So when you are using a triangle method first, again, the first thing is select a scale. After selecting a scale, you will draw 2.4 centimeter. Then draw the second vector from the first vector. So we have to draw the second vector, and what angle it is making with horizontal is 45. So this angle is 45. So what will be this angle? It will be 180 minus 45, which is equals to 135. So this angle is 135, and you will draw from tail of the first to the head of the last. That will be your resultant. This is a triangle method. The first one was a parallelogram. Both methods, if you are doing accurately, like drawing the or using a correct measurement, you will get the same answer. The method, the type of the method does not make difference to the answer. The reason why I say I prefer that you use a parallelogram method, because in a parallelogram method, the angle between the two vectors is already given. So if angle is given, but in a triangle method, I have to find a new angle, because I'm not starting the two vector from same point. I drew a first vector, then I'm drawing the second vector from the head of the first vector. So I need this angle. So maybe you did any calculation mistake, then your whole answer will be wrong. Is it clear? The parallelogram and the triangle method to find the resultant of the two vectors. In question 2, a vertical tube containing a liquid, a metal ball is held at rest by a thread just below the surface of a liquid as shown in figure 2.1. The diameter of the tube is much greater than the diameter of the ball. The ball is released and it accelerated downward uniformly for a short period of a time. Describe what happened to velocity in a short period of a time as it is accelerating downward uniformly. So what happened to velocity? Because if object is accelerating, the velocity will increase, and the change in the velocity is constant, because they mentioned constant acceleration. It's of 2 marks. So how you will score a mark? Like if I say, if it originally it is 0, then example it become 10, then it become 20, then it become 30. So velocity is increasing, but the rate at which it is changing, that is constant. That's why the acceleration is constant. So velocity increases with the constant rate or uniform rate. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Why we cannot say the velocity is decreasing? Because in the question they mentioned the object is accelerating. So whenever the term acceleration is there, it means speed or velocity increase. That is the meaning of acceleration. And if the term deceleration is there, if they say it is decelerating, it means the speed or velocity decrease. Reason why we cannot say it reaches a terminal velocity in this part, as they already mentioned, that they mention here the ball is released and it is accelerating downward for a short time. So for a short time, only they're asking for a short time what happened. Then later what will happen, like example, when weight of the ball balances with the upward force, when there is no resultant force, then it will continue to move with a constant speed. But the part which they asked, like it started with 0 meter per second, then 10 meter per second, then maybe 20 meter per second. So here speed velocity is increasing, but the acceleration is constant. But later what happens, this velocity will increase and acceleration will decrease. How the acceleration will decrease and the velocity increase? As you can see, it changes from 20 to 25. So acceleration is 5. Here it's 2. Here it is 1. And if it is moving with a constant speed, no acceleration, then we call a terminal speed. But they did not ask for this remaining part. Only the first part they ask is what happened in a short time interval when this object is released. So its speed will increase with a constant rate. The ball reaches a terminal velocity. The second part, they ask, yes, definitely, Mohsin, it will not have the same as acceleration due to gravity. Only for explanation point of view, I took those values. The acceleration in a denser medium will be lower as compared to that in air. But just for explanation point of view, I took the value 10. The ball reaches terminal velocity. Describe and explain the motion of the ball when it reaches when it is released until it reaches a terminal velocity. So the meaning of a terminal velocity, when we drop an object, the object acts. Look, whenever falling objects are there, the speed always increase or constant. Speed does not decrease for falling object. So first, when it was accelerating, so here 0, then it is 10, then it becomes say 20, then it becomes 25, and then it will be 28. So what happened? Speed is continue to increase, but acceleration is decreasing, and when it reaches a terminal velocity, the meaning terminal velocity means constant velocity, and when the object move with a constant velocity, there is no resultant force acting on the object. So the points when you write this answer is of 3 marks. Initially the object is accelerating, and speed is increasing. When the speed is increasing, what happened? The increase in speed will increase the frictional force or drag force. Drag force means the force which opposes the motion, which reduce the which reduce the resultant force. Here, why you cannot write a air resistance? Because if you see the question, they are dropping this object in a fluid. A tube is there which is filled with a liquid. So that's why you cannot mention air resistance. But it's the same question, same idea, but you cannot write air resistance as it is moving through a fluid. Friction force of the fluids are known as viscous drag or a drag force. Air resistance is also, yes, you can write resistive force as well. And when a resistive force or drag forces balance with the weight, no resultant force act on the object, and acceleration, the object will move with constant velocity known as terminal velocity. Is it clear, this question? The next question, the metal ball has a mass of 2.1 gram. Keep in mind when you use the values units, it should always be in SI. It fall at a distance of 0.8, so we know the height, we know the mass, but the mass in gram we have to convert into kilograms, so it will be 0.0021 kg. Divide by 1000. Calculate the gravitational potential energy. What is the answer for gravitational potential energy? So it will be mgh, mass into gravity into height. So what's the answer for the gravitational potential energy? 0.017 joules. 0.0168. And then when the ball reaches the bottom of the tube, it has a speed of 1.2 meter per second. Calculate the kinetic energy. So when it is coming down, like originally it was having potential, when it is coming down, it will have kinetic. So, but here not all of the potential change to kinetic, otherwise we can directly use this answer. So kinetic energy is half mv square or 0.5 mv square. The mass of the ball is 0.0021. The speed at which the ball is falling, that's given 1.2 and then square. What is the answer for kinetic energy? .5 into 0.0021 into 1.2 square. 0.00151 joules. So you can clearly see originally it was having a higher energy. When it is coming down, it is having low energy. What happened to the remaining energy? That is actually lost due to the work done against the resistive force, like the forces which are opposing its motion. It is using energy to work done against them. So explain why the calculated value in C1 is different from that of C2. because some of the energy is wasted or used up to work done against the resistive force or forces of the fluid. Next question, a U-shaped tube of a constant cross-sectional area containing a water of density 1000. The side of U-tube are open to atmosphere, shown the water levels in the two sides. So you can see the water level in the two sides are equal. It means the atmospheric pressure balances both sides. But when we place a rubber tubing connected to a gas supply, so by looking at this figure, you can identify that the pressure of the gas is more than pressure of atmosphere. So we can write the expression that the liquid pressure due to difference in the level, the atmospheric pressure is equals to the gas pressure. So pressure exerted by the gas is equals to pressure exerted by liquid plus pressure exerted by atmosphere. In the question, the atmospheric pressure is 1 exponent 5 Pascal. That's a normal atmospheric pressure, which is also called 1 atm. The left hand side of the tube is now connected to a gas supply using a length of a rubber tubing. This caused the level of water in the left hand side to drop by zero point 0.2. Calculate the pressure of a gas supply and give your answer to 3 significant. So if it dropped by 0.2, how much it will rise? So it will rise to a same level, because like if it move 0.2 down, then on the other limb the 0.2 will rise. And when we calculate the pressure exerted by the liquid, the pressure exerted by the liquid is equals to density, gravity and height. What height we take? We take the difference in the level of the liquid in two columns. So we take this difference. So this difference, the height will be 0.4 meters. So pressure of the gas supply. So the pressure of the gas supply is pressure due to liquid plus pressure due to atmosphere. Liquid pressure is density, gravity and difference in the level. And this is actually a manometer. Density is 1000 multiplied by gravity is 10 and the depth is 0.4 plus 1 exponent 5 Pascal. We'll get the pressure of gas supply, which is 1.04 into 10 to the power 5 Pascal. Figure 3.3 shows the gas supply is now connected to a cylinder that contain a piston. The rubber tubing connected to gas supply. This side is open to atmosphere. The pressure of the gas moves the piston to the right hand side. The area of the piston in contact with the gas is 0.025 meters square, and the resultant force, we need a resultant force on the piston. So we already, in the previous part, we already calculated the pressure exerted by the gas. So pressure is force by area. What is the pressure? So as you can see, they specify this. As this rubber tubing connected to a gas supply, and we calculated the pressure exerted by the gas. What was the pressure exerted by the gas? That was 1.04 into 10 to the power 5 Pascal. And then figure 3.3 shows a gas supply now connected to a cylinder that containing a piston, and the pressure of a gas moves the piston to the right. So it is moving the piston to the right, and the area of the piston in contact with. So basically, what is the resultant? Because we have the formula pressure is equals to force by area. So we need the force, resultant force. So resultant force is pressure multiplied by area. But what about the pressure? As we already calculated the pressure exerted in the piston, the pressure exerted by the gas is equals to 1.04 into 10 to the power 5 Pascal. And what is the pressure exerted by the atmosphere? That is 1 into 10 to the power 5 Pascal. So what is the resultant pressure on this piston? Because like atmosphere is pushing it from left hand side and the gas is pushing on the right hand side. So what is the resultant pressure here on this piston? Because that resultant pressure will cause the movement of the piston, and that will create a resultant force. So we will subtract these two to calculate the resultant pressure, and that resultant pressure multiplied by area. So 1.04 into 10 to the power 5 minus 1 into 10 to the power 5. So that is equals to 0.04 into 10 to the power 5, and multiplied by area, we will get the force. Is it clear, this part? Maybe you substituted the pressure of the gas directly. Look what happened when we connect a gas supply here. So gas is applying a pressure of 1.04 into 10 to the power 5. The atmosphere is applying a pressure of 1 into 10 to the power 5. So what is the resultant pressure on the piston? 1.04 exponent 5 minus 1 exponent 5. So resultant pressure is 0.04 into 10 to the power 5. That is the resultant pressure. And the area is given 0.025. So the resultant pressure multiplied by area, you will get the resultant force. The pressure of the gas causes the piston to move a distance 0.5 meter. Work done is force multiplied by distance. So the force you already calculated, a distance is given, you'll multiply them and you will get the work done. Even they did not mention even in exam, for example, they did not use the term resultant, but it should be done in this manner. If you know the inside pressure and you know the outside pressure, you always take a difference to calculate the resultant pressure. If they did not say that calculate a resultant force, and the question was calculate the force due to the gas on the piston, then we will not take a difference. But if they say calculate a force on the piston, it means they're asking for resultant one. Question 4, I will share another link and continue the discussion.